Let's remember how to graph rational functions. Do you remember the shape that these things make? Yeah, very good. And this one shifted. Which direction? Right, left, up, or down? Do you remember?
Right, left.
Left 2 units. There's no vertical shift. If there's an odd degree, so it's x plus 2 to the first power, then they are in opposite quadrants. What's the domain? What's the only value you can't plug in for x? -2. Does everybody see if you plugged in -2, you get 0 in the denominator? You see how that shows up in the graph? So therefore, the domain is x cannot be -2. The range, y cannot be 0. We want to list the vertical asymptote and the horizontal asymptote. The vertical asymptote is a vertical line. It happens right here at the domain disruption. We have x equals -2.
Is it always going to be like that?
Where it matches. So if you look here, see how this graph never crosses over this line right here?
Yeah.
So y can't be 0. Yep. What? No, it doesn't.
So then that's why we get x doesn't equal -1.
Yes. So it does cross -1. See -1 right here? It crosses right there. It has a value, at -1 has a value right here. Better? Okay, horizontal asymptote, y equals 0. What makes the next one different?
It's squared in the bottom.
Squared in the bottom, what's that going to do to the shape? Same, yep, very good. They're adjacent to each other. So first of all, what's the shift? Right, 3. There's no vertical shift. What is the negative going to do to it? It's going to make a flip. What does the 2 do? It technically creates a vertical stretch, but in your words, nothing. It does nothing to our general shape of the graph.
Okay, so wait. I don't remember how
The x minus 3 shifts it right 3. The negative on the outside creates a vertical flip. The 2, disregard it. Are you wondering right now about a vertical shift?
No, I don't know.
The vertical shift is going to happen with the next one because the +3 is at the end of the function or the outside of the function. All right. What's the domain? Well, that's a really ugly graph there, huh? Try to go like that. All right, domain. X can't be 3. Range. You're right, y can't be 0, but as I look at the graph, is y ever equal to 2? Is y ever 6? In fact, y is always less than 0. It can never cross over the 0. I have vertical asymptote, which is right here. X equals 3. And I have horizontal asymptote of y equals 0. We do one more together, then you're going to try one on your own. Yep, very good. This one means up 3. What is the, but there's no horizontal shift, is there? Okay, I hope that you make this connection. What's the value you can't plug in for x? 0. Notice how that's where the asymptote is? Okay, that's part of what we want you to see. And then I'm going to draw this graph. Yep. Domain, anybody? Range? Good. The vertical asymptote is x equals 0, and the horizontal asymptote is y is equal to 0. Try that one on your own. Go. Question. So Olivia, just to make sure, but Trey brought this up. Yes, horizontal asymptote. I apologize. It should be, if you look horizontal asymptote, should be 3. So somebody probably even said that. I don't know what happened. That was a. Sorry about that. Yep. So go ahead and finish that off. I have the answers posted up here. Does that connect with what you have? Is there any point of confusion? Okay, we've got 2 of them. Go ahead.
So why? So is it always like it's always going to be an arrow at quadrant 3? Or in the bottom left, there's always going to be a quadrant. There's always going to be arrows there.
Like here and here. So we'll always put arrows on the end of everything.
No, I'm sorry. I'm trying to get up.
Yeah. No. Go ahead.
So it's like majority of the time, like there's always going to be like something here. Here's like here.
No. If we would have made this negative, then it would have flipped up there, and you wouldn't have anything down there. And if this would have been positive, then it would have been up there instead. So it could very well not be down in quadrant 3.
How do you know if it is in quadrant 3 or not?
You have to just consider the shape of the graph. So as you see a squared, that makes them both above like this. The negative flips them below.
Oh, because it's minus.
Yep. Okay. It was Whitney. No, Marissa. X and Y. Please go ahead. So you're good? Laura? Is that a Laura question? Laura, eyes up here real quick. If the graph was like this, okay, the blue and the red, then it'll be y can't be 1. But because they're both below, its y is always less than 1. See the difference? Okay, flip it over. We do 2 more problems, and you'll be ready to work. Okay, so did you notice that what we did was review? That was to try to prime your brain so you could do the next thing. So this you need to lean into just a little bit. Not super difficult, but definitely just a little bit different, okay? So we are going to identify 2 new things. We're going to identify a y-intercept, and we're going to identify an x-intercept. Clean my boards today.
They're beautiful.
Thank you. So if I quick draw a graph here, and I have something that crosses the x and y axis, we call that the y-intercept, and we call that the x-intercept. Now, if we were to make a coordinate for the y-intercept, which coordinate do we currently know?
0.
For which one? Everybody agree the x is 0? And then for here, we know that the y is 0. So we're going to use that to our advantage as we graph this. That's something we kind of want to become second nature to you. It works out a lot for a lot of your functions. If I want to find the y-intercept, you said I plug in 0 for x. Everybody agreed? So if I plug in 0 for x, I get 0 over 3, which is? That means it crosses the x-axis at 0. I'm sorry, the y-axis at 0. Fair enough? Now, the x-intercept, I plug in 0 for y. Watch this, because I'm going to show you a quicker way of working through this. If I have a y value of 0, or 0 over 1, and I set that equal to x over x plus 3, watch what happens when I cross multiply. What happens to the denominator? It just disappears, doesn't it? See that? So because the denominator will disappear when you cross multiply, you don't have to look at the denominator. Remember, a fraction is equal to 0 when the top is 0 or when the bottom is 0. Which one? That's undefined, right? That's equal to 0. We don't care about the denominator. We're concerned about the numerator. So when is the numerator equal to 0? When it's 0. Look at this one right here. Look at the next one. When is the numerator equal to 0? For what value of x? 4. So that means the x-intercept would be 4. See my point? When you're finding the x-intercept, you just have to look at the top, not the bottom. All right. So I've got those two things. So I know it crosses right here. So I've got a point. I've actually got a coordinate. That's kind of neat. I've got something else going for me. The vertical asymptote. If you didn't notice, the vertical asymptote always happens when the denominator is equal to 0 or where the function is undefined. What value can you not plug in? So therefore, the vertical asymptote is x equals negative 3. Please do not write negative 3. Write x equals. It's an equation for a line, not a number. We all good with that? Okay, now to find the horizontal asymptote, I got some different work to do. What makes this problem different from the ones we were working on before? There's an x in the numerator, and so it's not in the form that we like. So we'd like to just simply put it into a different form. It's not that big of a deal, but we're going to use a skill that we've learned in this last unit. We're going to take x plus 3 and we're going to divide it into x. Fortunately, we already know how to do this, don't we? What do you multiply x by to get x? So I multiply the 1 back through and I get x plus 3. Subtract. So that's my remainder, correct? Watch how I write this. I have 1, then minus 3 over x plus 3. Remember how we wrote that? The remainder over the divisor. Or maybe you would feel more comfortable seeing it like this. Negative 3 over x plus 3 plus 1. Do you agree that those are the same? And isn't it true that that's what we just started graphing on the very first page? What's the shift if you look at this? And did we move left 3? What's the vertical shift? Up 1. So the horizontal asymptote is y is equal to 1. So when you divide it, you can find out that horizontal asymptote. And now, if you were to forget which quadrants they're in, you have this point right here, right? So am I going to be above or below? Below. You can see it right there. Kind of nice. That was new. When we do the second one together, trust me, it will come more intact for you. Ask the question and I'll decide whether we should wait or take it. Cross is right there. Yes, crosses at the origin where the x and y axis meet. Gave me a coordinate. Watch how it turns out in this one. Works out even nicer. Who can tell me how I find the y-intercept? Plug in what?
No, plug in what equals 0 in the numerator.
If I want to find the y-intercept, I plug in 0 for x. If I plug in 0 for x, I get 4 over negative 1. Yes? Which is negative 4. So it crosses the y-axis at negative 4. In order to find the x-intercept, what do I focus on? The top. Yep. When is the top equal to 0? 4.
So the top y-intercept we plug in
0 for x. X-intercept, just look where the top is equal to 0. Vertical asymptote. For what value is this function undefined? 1. So x equals 1. So I've got a vertical asymptote right there. Look at where it's undefined. And that will be confirmed when we divide. So I'm going to set up my division to get the horizontal asymptote. How do I set it up? What goes on the outside? X minus 1. What goes on the inside? Can I write negative x plus 4, just as Mr. Gavin said? You all good with that? So I'm going to write it as a negative x and a positive 4. That way I can take care of my division easier. Sydney? Okay. What do I multiply x by to get negative x? Multiply, and I get negative x plus 1. Subtract. Tim? Subtract, and I get 3. So that's a remainder of 3. Yes. That's the denominator. It's okay. All right, so I have a negative 1 plus 3 over 1. Okay, or you could write it as 3 over x minus 1 minus 1. Right? So when you look at that, okay, because that's what we practiced at the beginning of class today, what's the horizontal shift? Do we already have a horizontal shift to right 1? Yeah, that's nice. And then what's the minus 1 do? Down 1, so I'm going to mark that. Okay, so I've got y is equal to negative 1. And then, here we go. You can see we have those coordinates there that help us see exactly where our graph's going to go. Laura, remember your question about the x and y intercepts and why we found them? See how these play an important role right now? Yep, very good. Take out your worksheet. Yes.